Hmm.
Alright, guys, make 3, 2, 1. I love.
That's so funny.
I bet you some binge watch this in the future. You're sick too. Yeah.
Oh yeah. Random people in the future that have been sick.
It's like when you were like this. Oh yeah. It's when you were thought I was doing television station, like the video.
Uh-huh. I'm gonna have to do this. This I can probably push up. Yeah, there it is. More out of the way. Not have to do that little guy out of the way. Okay. Anyways, let's go with it, guys. Today is the day we're gonna create new trig functions. We've heard of sine, cosine, and tangent, cosecant, secant, and cotangent. That was cool. We made 6 functions. We're gonna create 6 new ones today, and it's gonna be based upon the trig function we created already. So now we're gonna have what, 12 functions altogether? Yeah, 12 functions altogether. So let's go with it here. So first things first, let's talk about what in the world does it mean to be inverse? Did you guys, or can you guys, anybody remember from Algebra 2, what is an inverse? That's okay if you don't know. That's good. That's where we.
You multiply it by it.
On that kind of thing.
Ooh, that's cool. Okay. So if you multiply the function with its inverse, it's 1. That's cool. But then the question is, what is an inverse function itself? So let's go with it here. Inverse function undoes the work of the function itself. So good example is x plus 4. That is a function, right? What does that function do to the x?
It's 4 to the x.
That's 4 units, right? That's cool. What would be the inverse function?
-4.
Minus 4 units. Perfect. And then you guys tell me, agree or disagree here. So if I plug in a 3, I'm going to get out a 7. Is that true? Yep. Okay. So then the inverse function, now we got some notation here. Ready? Inverse function, if you see a negative or -1, should be a -1 right there. If you see a -1, almost in the place where an exponent should be, but the number's not a number. The base of that is a function. We good? If the base of that is a function and there's a -1 in the exponent slot, that means inverse. So let's talk about that. This is kind of interesting. If I have a number like 5, right? 5 to the -1, right here on the bottom. Anybody know the name of what does that do? What's the process if I have a number? Reciprocal. Everybody agreed with that? Is that right? So if you have a number, a -1 in the exponent slot of a number, that means reciprocal. If you have it in the function name, that means it is inverse. Are we good? So, want to tell me here, what function, what something is going to take 7 and make it a 3? What's the process? Or what's the inverse of x plus 4? X minus 4. All it is undoes the work of the other. We good? So notice what happens, the x's and y's have to switch because instead of going adding 4, now we're subtracting 4 each time. Okay. Are we jamming? Are we good? Some other ones here we should note. If I have this, if I have 4 minus 1, what is that?
3.
It's 3. What does the -1 do? What is that like? It's a subtraction of 1. True. So this is reciprocal, just for funness. And then we have a negative, right? Oh, I don't see the -1 here because of the little zoom thing majiggy. Let's see if I move this up. I can move it up. Okay. Okay. If I see like a negative in front of a number, we call it a negative of that number, right? Like -12, -42, right? If I see a almost like a -1 after a number, it means an operation of called minus. Is that right? This is crazy. And then we have reciprocal and then we have inverse. So based upon where the location of that symbol is, and then also tells us 4 different stories. Are we good? It's almost like when in English, if we say 2, right? What does 2 mean? Is it too much? Is it going to the store or getting to cartons of eggs at the store, right? So all that, just the context itself gives you the placement of what it means. Okay, so in terms of trigonometry now, so what it is, a in trigonometry, what we've done is we've done this so far. Is that right? We've taken a degree, sine of 60 degrees, or cosine of pi over 3. We take a degree or radian measurement, pi over 4, and we apply a trig function to it. Is that right? And what we get out is we get out a ratio. Is that right? What we've done so far? We want to go backwards. So here's what we do for the inverse. Inverse says, I'm going to give you root 2 over 2. That would be my opening statement to you. We good? We're going to go through a process called the inverse sine. What's someone going to use for inverse? -1. It's going to be the -1 right there. And so be sine inverse of my ratio, which is root 2 over 2. And I'm going to get out a pi over 4. Yeah, pi over 4 or 45 degrees. I'm going to get out a radian measurement or a degree measurement out of this. That's what we got. We good? Let's jam. Still writing it down as you guys are writing it down. Let's see. And let's do one more thing with these with inverse functions. Let's do a graphical approach to inverse functions. And hopefully this is making sense so far. So far, so good? Too easy. All right. So graphically now. Just a second. Okay, cool. Boom. So let's do one more thing here. Let's do graphs. I have x squared on my hands. And I'm just going to use the 0.39 just for example here. So I want to tell me, what is the reciprocal function of x squared? What takes 9 and makes it a 3? A square root function. Everybody agree there? I need a function that does this. So the inverse function of a square function is the square root function. Now the only little problem we have is we have this. So let's kind of put our minds here. X squared, doesn't x squared look like this? Is that right? There's 3, makes a 9. Is that right? But hold on though. Doesn't a -3 also make a 9? So if I go backwards on this, I'll go from 9 goes to 3, but also 9 can go to -3 as well. We're good? They can go to 2 different spots. Guys, real quick, is that a function? Because remember in algebra, right? A function says if I take one number, I give you a number, you have to only give me one number back, right? It's a function. But here we have 2 different functions. If I say 9 and I say inverse of x squared, some of you guys will say 3, some of you guys will say -3. We're good? So here's what we have to do. We have to define it in such a way that we're only getting one number back. We can't get 2 numbers back. And so what we do is we chop. What we're going to do is we're going to chop off one of the sides. And notice real quick here, and this is important here too here. So notice this guy, functions, I think in algebra had to pass a vertical line test. Remember those vertical line tests you guys did? Mm-hmm. For the inverse to be a function, it has to pass a horizontal line test. Does this guy pass a horizontal line test right now? How about if I chop off this side? Now does it? Yeah, so what happens is I have to chop off the side, then it gives me only one answer. Are we good? Okay, so here it is. What is the inverse function of x squared? It's just going to be the square root of x. Now I can't put plus or minus in here, right? I just want the plus value, right? That's why this works, is because I'm only using the plus value as my. So let's see if this works with trig functions. Ready? So here it is. In order for the inverse to be a function, the original function has to pass a horizontal line test. That's all we got. We're good? So then let's jam. Let's look at the sine curve. Oh, we will. Absolutely will.
It does.
So here it is. Does this guy pass a vertical line test? Yes, because it passes a vertical line test, we know the sine is a function. Does this pass a horizontal line test?
No.
No. And if it doesn't, that means right now the inverse of this is not a function. We're good? Unless we can limit our domain.
What are the line tests again?
See again?
What are the line tests?
Oh yeah, line tests. Here it is. We have two of them, right? Let me go back real quick here. Like this. So vertical line test. Let's see this right here. A vertical line test means the graph that I'm looking at is a function. So let's talk about it here. Let's see. Let's say this here. Let's say this is time, right? Let's say you woke up in the morning, you were at home, right? And then you're now at school, like this right here, right? So in physics and the known world, if I give you one value of time, and this is the distance away from home, right? You have to be somewhere on here, right? You can only have one point at which can't say at 11 a.m. how far are you away from home.
It's like you can't cross the same. The vertical point would be you can't say like 3 on the y-axis. The line can't cross there twice.
Correct. Yeah. So right here,
Same.
so you can't be 3 miles away from home at the same time, 5 miles away from home at the same time. So that fails the vertical line test. So let's go with it again. So you guys talk to me here. So I got this right here. Does this pass a vertical line test? Vertical line test, it does, right? Because you come down. Well, sorry, this was kind of super close right here. So yeah, it passes the vertical line test because I can go like this right here, right? That means for every x value, there was only at most one y value. Good.
It does not pass the horizontal.
It does pass horizontal, but it passes the vertical test. So that we know that this function here is a function. Whoa.
So the original has to pass the horizontal in order for it to be able to have an inverse.
Mm-hmm. The inverse to be a function. Okay, how about this one? No. Nah. Okay, we're good? Okay, that does not pass a vertical line test. Therefore, this itself is not a function, right? The rocket can't be at two places at once. Okay, but the horizontal line test says this. If it passes a horizontal line test, that means the inverse of it is also a function. That's what we're looking for. So here it is. Originally, my domain for the sine function is negative infinity, positive infinity. What's the highest sine can go? And what's the lowest? 1 at -1. Perfect. Okay. So here's what we're going to do is we're going to limit our domain. We're going to have to scratch this off so that this passes a horizontal line test. Let me start it, and then we'll see how we go. So if I scratch that off, are we done? So all I'm doing is just I'm taking part of the graph off. We good? Are we good there? I'm going to take off part of this one. Now does it pass a horizontal line test? No, not yet. Okay, so let's take some more off. How about if right now?
No.
How about now?
Yes.
No, that little bottom on that side's still a problem, huh? And then how about now?
Yes.
Yes, okay. We have passed the horizontal line test. What does that mean? The inverse of whatever this is itself a function. We're good?
Mm.
Sweet, okay.
So it's the reason it works.
So again?
We can delete parts of it until it works.
Yeah, just like we did for x squared. Let me see if that makes sense. Let me show you. No. Yeah, if it's messing with you, hold on. Let me see if I can do it a little more here.
I just don't see how we do it. Maybe it's just short. Like, so instead of making 10. Oh, so we're just changing the what it's called. Okay. Yeah.
Okay, let's see. Well, just a little bit more just to make sure it would make sense here. So we know a function does this right here. If a number goes in, whoa, come on. All right, if a number goes in, a number has to go out, right? That means it's a function. right? Okay, so let's do this here. So if my function, just off to the side here, my function is x squared. So if I plug in a 4 into here, that's give me 16, right? A function in gives me a function out, right? Um, and the graph of it goes like this right here, right? So it does pass the vertical line test. It is not going to pass a horizontal line test. That means if I were to create an inverse of this, it's going to give me two numbers, right? So if I have this, let's say if I have, you guys talk to me. If I have y is equal to x squared, right? And I'm the one taking the square root of both sides, right? Do you guys remember in algebra what we had to do is we had to do plus or minus? Is that right? If we do this, we do plus or minus. Whoa.
It's the trapeze.
Sorry, Natalie, it's good. So we'll see if this makes sense here. So if I do this, if I'm the one doing the square root, I get a plus or minus out of it. So notice the inverse graph of this guy is going to look like this. Does that pass a vertical line test? So notice a horizontal, yeah, so a horizontal line test here becomes a vertical line test here. Now, what is this function right here? If I was going to, what is this graph here? This graph is plus or minus the square root of x. That's what that is. So if I were to plug in a 16 into here, what's my output? Yeah, -4 and a +4, which now fails my definition of function. We're good? So then, and that's not a function. I got to get rid of one of them. So what I do is I'm going to get rid of the negative values here. So I'm going to get rid of all the negative x values here, which will also get rid of all the negative y values here. So now do I have a function? Yeah. And that one is I'm only taking the positive values this time. So now what is the square root of 16? Just a +4. And now I got myself a function. Ooh, okay, so now there it is. So now let's see. What is this point right here then? If I was going to go along my graph and I find out the low point of this guy would be a -π/2, are we good? Or -90 degrees. That is the point that I see here. We good? And then what's my high point? This will be π/2. And then +90 degrees. Okay, guys, so this is kind of weird. Okay, so let's take our unit circle. So I want to know which quadrant is this? Which quadrant is from 0 to 90 degrees?
Quadrant 1.
Everybody agreed with quadrant 1? Okay, here's the weird one now. Ready? Which quadrant is this that goes from -90 degrees or -π/2 to 0? It's going to be quadrant 4, but it's not the way we think about quadrant 4. It's the negation of. So let's go. I know this is weird crazy. Ready? So the unit circle I gave you guys just now, right? This is let me go back. Let me go back to here. Let me go all the way to here. Sorry. We'll get there. We'll get there. It'll all make sense in just a second here, guys. Let me go to here. Now I'll show you a little something extra here. Nope, I don't have the unit circle here. Hold on, just trying to find the unit circle here. There it is. So unit circle, we just said that the inverse function operates from -π/2, right? To π/2. So it is in quadrant. It's from here. Is that right? It starts here. And then it ends here. It's on this side. But notice in order to get to these values here, let's do this here. I think it'll be helpful. Whoa. That's weird. These guys are negative values. So next to 330, what you want to write is you want to write -30 degrees. And then you're going to write -45 degrees. And you're going to write -60 degrees. And you're going to write -90 degrees. So we're going to go backwards, right? We're going the negative direction from 0.
Mhm.
And then the same thing we got to do with the radian measurement. So this is negative pi over 6. This is negative pi over 4, negative pi over 3, and negative pi over 2. Good. So I can't really see it here. So I'm going to write it on the outside. We good. So negative pi over 6 would be the first one, negative pi over 4, negative pi over 3, and then negative pi over 2 would be these little lines right here. Okay. Talk to me. Are we okay? Let me go back to the graph to see if this makes sense. Zoom. And then we'll put it all together here. So we are here. We did that. We chopped it down to this. Is that right? But here's our problem. We're starting at 0, right? So if I were to start counting my angle measurements here, right? It would be pi over 4, right? Or pi over 6, right? Pi over 4, pi over 3, pi over 2, right? Because they're going forward, they're going positive, right? But if I'm at 0, what are the values here?
Negative pi over 6. Negative pi
Yeah,
over 6.
I'm going to the negative direction. That's why. So then that sort of quadrant 4 has to go in the negative direction with me as well. All right, so this is in order for my inverse function to be a function. This is for me to put a value in, and I'm only going to get one value out. We're good? That's what I got. Okay, I want to show you one more thing. What's the graph of this look like? If I were to switch it around, if I switch x's and y's, the graph of it looks like this. There is the graph of my inverse function. Kind of looks weird, doesn't it? It's like the x and y got switched. So this is pi over 6 right here, pi over 4, pi over 3, and pi over 2.
Looks like we're taking constant.
Mm-hmm. Okay, then one more thing I want to show you just visually, just sort of see if we see it here. And this is inside your textbook as well, so I don't need a graph of it per se. How about this? How about if we kept the sine function exactly the same, and we switched the x and y's to make the inverse function, right? What is it? What do they look like? Good. That's what I want to know. So let's do that one, and I think they'll kind of make graphical sense here. So here it is. I'm going to put in one second this guy. So on the left hand side, that's my sine curve. We're good. And on the right side, that's my sine inverse, but without any restrictions. We're good. So let's see if this would actually make sense here. If I am going to get rid of this side right here, I'm getting rid of this and going all the way to here. That is the same thing as me getting rid of this right here. All the negatives up to this point right here. Are we good? So notice, does this guy pass a vertical line test?
No.
Not yet, huh? Not yet. Okay, so we have to make it pass the vertical line test. Okay, if I start restricting this guy, I restrict this guy, restrict up until here. That's the same thing as me restricting the positive side up until here. Now, does that pass a vertical line test?
Yes.
Yes. Okay, we good? But we are restricted to quadrant 1 and 4, right? And quadrant 4 being like a negative values. So kind of crazy. So that means if the angle is positive, I have all the positive values sine can give me. And if the angle is negative, I have all the negative values sine can give me. That's what I have. Okay, so let's do some work here. So we're only in quadrant 1, only in quadrant 4, and the quadrant 4 is a negative quadrant for us. Good? Okay, so let's see if we can get to do some work here. I need to know this. My first exercise problem of the day. Evaluate the function. I should say in radians. And I think this one's in radians. Let's see. I know one's in degrees, one's in radians here. Radian. I can spell it. Okay, this side's going to be in radians. So looking at your chart, you guys ready? Look at your chart. See where you have 1/2 as your ratio. I need you to give me the radian measurement that sine gives you 1/2. 5 or 6 is good. Are we good?
Yeah.
Perfect. Okay, then give me when is sine inverse of 1/√2. So only looking at quadrant 1, only looking at quadrant 4. Yes, this is a sneaky one because remember, yeah, √2/2 is the same thing as 1/√2. And we got ourselves pi/4. Perfect. How about this one? That's pi/4. Yeah, pi/4. Same spot, right? Same exact question, just kind of stated differently. Yeah. Okay, and then I'm going to throw in one more here. Let's see. Why did I not throw this one in? D. Sine inverse of negative √3/2. All right, anybody give me that one? Oh, -0, sorry. All right, sine inverse of a negative √3/2.
5/3.
No.
Oh wait, negative. Wait. Oh. Negative pi/3.
Here we go with the negative pi/3. Right, it is the going the negative way into quadrant 4. All right, how about sine inverse of negative pi/2? Going the negative way into quadrant 4. Oh, I'm so sorry. Duh. It's supposed to be -1 here. So sine inverse of -1, and the answer would be negative pi/2, right? Okay, sine inverse of 0.
Negative. Yeah, it's fine, just fine. Where's here?
So we're just looking for what quadrant 4 and quadrant 1, right? Anytime you have a y value of 0, is at 0. Uh-huh. Okay, are we good there?
Mm-hmm.
Let's flip just a little bit here. Let's go and change it to degrees, and let's see if we get through cosine as well here. All right, exercise 2. Evaluate the function. Now I'm using degrees. So give me that. So this is degree measurements now. Boom. Anybody with an answer there?
60 degrees.
6 degrees is good. Uh-huh. Ding, ding, ding. Ooh. Oh, can't do that. 90 degrees is the top of it. Try not to give the answer now.
-45 degrees.
Negative 45 degrees. Agreed. Are we good there? You guys talk to me if that is making sense. All right, and one more. How about sine inverse of -1? -90 degrees. Are we good? That is going down from 0 into quadrant 4, the negative way. Are we good? Okay. Now let's do this for this is for cosine. Dun, 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 dun. Cosine. I need you guys to restrict the domain, and then tell me where the domain is so that we pass a horizontal line test.
Wouldn't it be from negative pi to 0? Wait, that doesn't seem right.
If I chop off this side like this, is that good yet? If I chop off this side over here, is that good? Well, that's like
No.
Oh.
Yes.
Yes.
Okay, 0 to pi.
0 to pi. Are we good? Oh, perfect. Yes. Okay. So here is the fun part is we get to decide if we want to chop going from negative pi to 0 or from 0 to pi. We're good. Both of those will pass a horizontal line test, right? Which one is the more like a natural fit?
0 to pi.
0 to pi seems to be more natural. Yeah. Perfect. Okay. So let's go back to unit circle. If we go back to unit circle, question is, which quadrants are we using? And are it negative or positive for those quadrants? Like what are we using here? So from 0 to pi over 2, which quadrant is this? Quadrant 1. In the positive direction, is that right? How about this one? From pi over 2 to pi.
2.
That's quadrant 2. It's still also in the positive direction, right? So good. With cosine, we don't need to mess with the negative stuff. We're good? So we are going to go from 0 to pi or from 0 degrees to 180 degrees. That's the only answers that we can have. Are we good? Let's try it. Boom. So let's start off with degrees now. Let's go degrees. So quadrant 1. Man, that's cool, guys. We just built 2 new functions based on what we did before. All right. Let me go speed through this here real quick here. Oh boy, too fast, too fast, too fast, too fast. Oh no, I gave the answers as well. That's no fun. Okay, I have to give it to you guys here. So if you guys want to write it down and then tell me if you agree. Maybe I did it wrong. Not sure. We'll see.
Inversely.
That's right, because I moved the slide over, then I forgot to do the animations to it. So cosine inverse of 1/2. So now you're looking for the x coordinate, right? Along your unit circle. And you're going like this right here, right? You're going from 0 and you're searching from here to here. That's what you're doing. You're just looking at the top half of your unit circle. So
if it's from quadrants 1 to 2, it's going to be positive. But if it's quadrant 4, it's negative.
yeah, in the negative, we say in the negative direction.
Yeah.
Mhm. All right, are you guys good? 60 degrees are agreed? And then negative root 3 over 2, that would be 150. Sweet. Okay. So then there's other notation. So we notice we have this little -1 in the exponent, right? That means inverse. The other way you can say inverse is, let me do this here. 1 second here. Ooh. I'm gonna do this real quick here. Ooh, just so. There. Just have a more natural feel to it here. Okay, exercise 4. Evaluate the function in radian measurement. All yours there. I want just to know the radian measurement of that. -1, the answer is pi, right? It's all the way around the unit circle or half the unit circle all the way to the end. Perfecto. Oh, it does go up there. Okay, that's cool.
Pi over 2. For 75.
Ooh, I think it is defined. Yeah. Pi over 2. You guys are good? Here, look at unit circle. When is the x coordinate 0? The x coordinate 0 at pi over 2. And cosine, they have -1. Oh, sorry, cosine of -1/2. Inverse cosine of, I'm sorry, inverse cosine -1/2. There you go.
Oh, wait.
2 pi over 3 it is. We good. That is so cool. Okay, I've created new 2 new functions. Okay, and the other one is you guys can see in your back of in your book. The other notation for it means cosine inverse. We're good, but here's your other notation like this. It's arc. Whenever you see an arc before cosine, it means cosine inverse. Oh, it means the same thing. And you'll have arc sine, arc tangent. You have all those, but arc means inverse. So what is arc inverse of a positive 1/2?
Pi over 3.
Pi over 3 it is. You guys good. Are these pretty easy? Sweet. Ooh, okay. And next, let's deal with tangent. What should I block off of tangent to pass a horizontal line test?
Oh, look.
Yeah, the 2 on the sides. Is that right?
2 on the side.
2 on the sides. I block this one off, block this one off. Bam, I pass a horizontal line test now. Cool. Where am I at? From where to where?
-pi.
Oh, gosh.
There's a line there.
No, I do. I go from -pi over 2,
Yeah.
except I don't include it because it never gets there, right?
Yeah.
So I'm also, oh, just like sine, look at this. I'm going to the negatives. This is quadrant 4 going into the negatives, right? From the negative side, and quadrant 1. So this works just like sine now. Glad we put those negative values in. Okay, tangent is a little bit tricky now.
It doesn't include pi over 2 or pi over 2. No.
Yeah, it doesn't include negative pi or positive pi over 2. So I can't say what's in tangent inverse of pi over 2. Okay, ready? 2 more problems here. This one's a little tricky with tangent, because here we go. Ring, ring, ring. That one. I need to know tangent inverse or arctan at √3. Now, the fun part about √3? Awesome. Oh, no. No. Here's what we got to do. Is it what? Pi over 6? Maybe I'm wrong. Let's see.
Yeah, just pi over 6.
Oh, gosh, I'm wrong then. Okay. So here's what I got here. This little guy right here, I'm going to have to make it like this. Is that right? Because I'm going to make it into a fraction first. And then this is what? This is y over x. Is that right? Tangent by definition y over x. But we don't have our variable of 2. So
Oh. So that would be
yeah,
pi
here's
over
what
3.
you're looking for. Yeah, you're looking for a y value of √3 over 2 and x value of 1/2. When does that happen?
Pi over 3.
Pi over 3. Good. And then one more. Tangent inverse of 1. When does that happen?
Inverse of
Oh, sorry, -1.
Wait.
Remember,
Oh.
tangent inverse is y over x, right? I want one to be positive, one to be negative.
Negative pi over 4?
Negative pi over 4. Are we good there? Okay, sorry, we're past time. We are 30 seconds past time.
No.
All right, we have not finished with this section yet. We're almost, but not quite. So we will do 4-7 on Friday.
Are we gonna be able to keep these in circles?
Yes, that unit circle is yours.
It'd be really helpful.
Class, let's see, I just might have a sub on Friday, but if I do, then I'm going to do a video like this as if I'm teaching the class the next part of it. So I'll review it and then we'll go from there. A speaker. Oh, gotcha. Thank you so much. Thank you guys. Yeah, I will find a speaker for that.
I lost. So there's this. So the same. Oh, yeah. I guess there was some people that were